number 7 here, you're finding the value of x. Here we are looking when a diameter intersects a chord. Here's the diameter intersecting a chord of EF. When a diameter intersects a chord, you get congruent parts for the chords. Therefore, you can say that 3x plus 16 is equal to 12x plus 7. Now we can solve for x. Minus 3x from both sides. This cancels, leaving you a 16 is equal to 7, 8, 9, 9x plus 7. 9, 10, 11, 12. That's correct. Then we minus 7 from both sides. Okay, this gets you 9x. This gets you 3, 9 is equal to 9x. Divide by 9, divide by 9. This cancels, leaving you with 1 is equal to x. Okay. Next, we take a look here. These two for B are chords. And notice that the chords here have the same distance. The fact that they're the same distance, we can now say that the chords are going to be congruent to the other chords. Okay, because they have the same distance away from the center from the circle. Remember, we proved this by looking at the Pythagorean theorem for it. Okay, so we can say that 3x minus 11 is equal to x plus 9. And again, that is because the arc of AB is congruent to the line chord of DC. Okay, minus x from both sides. This gets you 2x. Minus 11 is equal to 9 because this does cancel. We add 11 to both sides. 2x is equal to 20. Divide by 2, divide by 2. We get x is equal to 10. So there you go. That is how you solve from x using your properties of chords.